Hi and welcome to DCO. If you're new here, my name is David Copete. I focus on creating parametric scripts with Grasshopper. And so in this particular video, I'm sharing with you how to create this design. I'll be going over all of the steps in detail here, starting with the beam system, the columns. We also create a set of dimensions. And the dimensions are useful because we can see the size of the structure, we can see the number of subdivisions, and we can change all of those things here. So if we want the spacing to be 20, you'll see that here. Also, we have a pattern insert with some lights. So you'll see the script here. If you go to the website and download it, you'll see exactly how it was plugged in. And you can also download the cluster, which is the organized version of the script. So hopefully you're excited to see how this was made. Like I said, I'm going over all of the details here. I provide resources for those of you who are new to Grasshopper and want to learn how to program your own designs. So let's get into it. So the first thing I'd like to do is bring in a scale person. Also, I want to show you that the units we'll be using are inches, and that's my preference when I create designs. And the reason for that is because I can always multiply by 12 to use feet for a larger scale, and for a smaller scale I can just use the typical inches. So I'll hit OK here, and I'll start by bringing in a point component. So I'll go to construct, point. I'll use an empty point component so I can change the location. Now let's go here and create a rectangle, and this is going to be the base geometry for the design. So I'll use the point as a plane input. Now change the X and Y size. So I'll go here to 50 feet, which means I have to multiply it by 12. And if you've seen my last video, I actually have some converting units, which we can just do times 12. And we can use this as our feet. And I like to use that as a cluster. So when we do this, now this is going to be 50 feet. And now the Y size is going to be 50 feet. This is going to be the outside face of the design. Next, we need to offset where the structure is going to be. So we'll take this, bring in an offset curve. We'll offset by a specific distance. So I'll go here to a negative value because I know I want to offset to the inside. And so we'll offset, copy this over because I want to use feet. And now it won't work because it's offsetting by 50. So we'll make sure to decrease the max, let's say to 15. This way we can change the offset of where the design is going to go, and the offset is dependent on the overall size. So we'll make it a 50 by 80. Next is creating the outside beam. So this is going to be part of the structure that we need to offset to the inside. And I'm going to offset it by using inches. So this time I won't copy the cluster that has the conversion units, but I'll bring in, let's say 12, and offset this by 12 inches to the inside. So now using these two, I'll create a boundary surface to create a surface between the two. Notice that they are overlapping, so we'll flatten the input to make sure that we get the surface between the two. And so this is the kind of the beginning part of it. Let's see here how this changes. And let's also make this a range of numbers with 2 decimal points. It'll make it a little bit more subtle to be able to change this, and more precise as well. Okay, next is creating a surface located right at the inside offset here. So I'm actually going to do the outside, create another surface that overlaps this one, because this is going to be, so I'll hide that other surface, and I'll actually use a contour component to create a set of contours both in the X and Y direction. So I'll start by going in the X direction, so we'll use the surface as the shape. The point is going to be the middle of this surface. I'll go here to area and use the centroid as a point where it's all going to start. Then the direction is going to be in the X direction. And the distance I want to use in feet. So I'll go here to this component and change the maximum number to, let's say 25. And we'll use that as the distance. So the idea is that we can create a set of beams that are offset by a specific amount. So we'll go here to 20. And I also like to wire display hidden, so we don't disorganize the script. Now using this, we're going to be doing the exact same thing, but not in the X direction, but in the Y direction. I'll take this. I'll even place this into a surface component and hide the input. It's this clean part of the script that we're going to be doing again. So hide this. I'll copy this down. Now change X to Y. We can also change that size or the spacing between the columns or between the beams. And so I'll bring back this one. And here, now we have the location of the beams. So now what we need to do is create a surface similar to the one that we have here, but I'm actually going to extend some of these. So I'll go here to extend. And I will extend the start and end by a specific amount. So we could use either feet or inches. Okay, I'll bring feet, 3 feet. And then the start and end will extend. We'll do the same thing to the other set of contours. So what this does is lets us extend this, so it goes past the beam, and so it has a little bit of an overhang. Next, we'll take this and offset it. We'll just say 3.5 inches. Then here in the negative direction. So by offsetting to this side 3.5 and this side 3.5, we actually have 7. So let's just divide the slider by 2. This way we offset half of 3.5 to one side, half of 3.5 to the other side, and making this 3.5, or we can even make it whatever size here, and it'll be accurate to the center line. So now using these two, I'll loft them together. And so now we have this beam. And we'll be doing the same thing to this one. So what I'll do is create a relay, create a curve input that has hidden wire. This will help keep it organized. And now we can do the exact same thing to the other one. So I'll copy this, tap Alt, and use this as the input. So we get our two sets of surfaces based off of the center line, and we can extend them. We can change the size here. So now we can move on to the next part. All right, so at this stage, we got two of these. So one thing we could do is extract where they overlap. So let's go here to region, intersection between this region and this region. Notice that we only get those diagonals. So let's flatten the input here. And now we're getting the overlapping columns here. The next one is going to be taking these two and using region union. Sorry, I got a dog making some noise back there. I'll do this one and this one. Notice that now those have been brought together into one. And where this region overlaps with the outside surface, we need to extract that. So we'll go to region intersection between this region and this surface back here, which is the outside beam. Now notice here that since this is a surface, we actually need to use we'll use a different one. Intersect B-rep and B-rep between this and this surface. There's sometimes different ways that we can achieve this. And I'll use this as B. Notice that now we're getting the outside ones. And if we want to keep things organized, we'll hide the input on this. Hide all of this. And these two will create surfaces at those locations. So we'll go to boundary surfaces and boundary surfaces on this one. Notice now that the column locations are based off of the size and offset of the columns and beams. Now what I'm seeing is that the center point, so we're getting an extra column here. I think that's due to the offset. We'll go to 20 here. Let's just change the size to 85 by 55. We'll go 18 this way and 18 this way. Now let's bring back our beams. So here we have a decision to make. Which one are we going to extrude first or move first? So I think I'm going to start by taking this and also adding an offset to the columns. And I'll just say, 5.5. This way we can change the size of the columns and not necessarily be stuck with the exact size of the columns that we have. We can make them a little bit larger, or we can make them 0. So this gives us a little bit more control. And now I'll take this surface and extrude it up. So taking this, I'll be extruding this in the Z direction. And I'll be using the conversion into feet. I'll go here to change the size. And so now that we've determined the height of it, well, we can move the beams up. So let's move in the Z direction these surfaces. So we can now hide this one. And also bring up the outside one, which is this one. So I'll hide and disable the preview on those, and then just hide the wire input. Next, we'll take these set of surfaces and extrude them up. I'll use this one first, up in the Z direction, and then use a number here, let's say 24 for the height. So this one I'll be extruding using the inches units. Same with this one. And now we can bring those together. But I'd like to just see and show you here how kind of this works. Now there's a spot here where when it overlaps, it creates a wall. That's just something to keep in mind. And then with this one, this one, if we offset it, it'll increase the size of the columns. And the cool thing is that offsetting it again, we can create the footing. I'll take this, tap Alt to create a copy here, and then I'll offset this by 24. So it's 24 and 24 this way, so it's 48. So, this is something that can change. But the cool thing is that we can use that same offset here, and now we can extrude it down. So we'll create a surface using boundary surfaces and extrude this down. I'll copy the extrusion components there. and it's extruding up, so let's extrude it down using negative. So now when we look at this, we see that we have the height of the columns, the height of the beams. Now we're going to be creating the floor slab. So taking the outside face of the rectangle, or the original one, let's take that and move it up in the Z direction. Here's the thing. First thing, we'll hide the input, but now we need to add the column height plus the beam. So I'll bring in a addition, and with vectors we can add 24, so 24 inches, and the height, which is this one, and using that as the input for the motion, you'll see that it moved it up there because we use both of those added together, and now we can extrude this up. So using boundary surfaces, we can take this and extrude it up. So we'll go to extrude in the Z direction. And using inches, we can extrude this up. Let's bring this down to 16. To keep things clean, let's hide some of the inputs here. I'm going to increase the size here. Let's just say 85, say 100, and then this one 80. $25 by $25. So this is going to be the module for the first floor. And all we need to do is take all of this and array it vertically. Except for the footings here. So we know we need to add this plus 16. That's going to be the height. So all of this plus this. And the cool thing is that we have all the work done here, so we can always go back and tie numbers together like this one, and now move first. Let's start by, because we're not necessarily just going to move it once, we're going to move it multiple times, but I want to show you first using columns. The beams. And the floor slab. So now this is a 2-floor. But notice that we only have 2 floors. And the reason for that is because we only added one number here, 160. What we need to do is take 160 and create a series of numbers stepping by that amount. So I'll bring in a series component using 160, which is going to be the number. The count is going to be how many. So we'll start with 3 and then override the input. Now we do need to bring back a unit Z because we're using this number as the step, and this will be the vector direction. And since we start at 0, then we need to hide all of the other inputs, well, except for the footing. Let's see why the columns here. So I had to graph that input for it to get all the columns. But now that we have this, the cool thing is that we can change. We'll change this. So now we can change all of these, and we can do multiple heights. So now this number will be the array of vertical copies. And so let's show you here some of the things that we can change still here. So first, let's visualize it a little bit better. We'll bring in a custom preview and also a color swatch. And I'll definitely like to hide the input on the custom previews. So starting here, I like to use lighter gray to start. And let's add the beams, which sometimes I like to make them a little bit darker so you can see the contrast. And then the floor slab. So we'll copy this again. And then we'll get a bit of contrast there as well. One of the things I saw that I would like to do is round the edges of this. So the way to do this is go to this line segment and create a relay here so I can use the curve input and use a fillet, but we can use it in feet here. Notice that it doesn't work unless you plug in a value. And this value is 5 for the fillet. All right. Next, let's do the footings. So I'll bring the footings all the way out here by hiding the input and bringing this out here so I can plug it into the custom preview. Let's also change some of these. I want to see how it changes. And if you wanted a wall on each side, you could actually do that with this, but that's not the idea here. Let's say the columns were 15 feet, 12 feet. Same with this one. And the cool thing is we can also change the size here. Here's the other thing about this design. We don't have a column at the corner, but if you have a column here and you have a beam that is at least a third the size of this member, then you can actually have that be connected and cantilevered, where it's actually hanging off of one of these sides. But those are the kind of cool things about this design. You can also change the size. So if the building is 50 feet, you can change that. And all of the subdivisions will change accordingly, because at some point you only have one, then you have two, and so on. So what I'll do here is dimension it, because I feel like this is something that would be very cool to see. So we'll take this, bring in the endpoints. And I'll take the, let's say these are going to be the start points, and move it in the negative y direction. So I'll go to move, negative, y direction, and I'll use the start point. We'll go here, let's say 24. It's actually going to be the endpoint then. Let's change this number. Now I'll connect those points here. So I'll go here to polyline, flatten the input, then explode, and use a curve or a line dimension. I'll go here to 24. And so here, you'll see that we have this dimensions for the columns on this side. Now we're going to do the same thing on the other side. So using these curves, we'll bring this down, tap Alt, and then use this as the input. Now you'll see that it's moving in the Y direction. So this is why we'll go in the X direction. And not negative, but positive. So looking at it here, we have these points and these points, which are technically line segments. So I actually like to connect those between the endpoint and this point. And do the same thing with this one. So using just one of these, I can use one of these sliders to offset the dimensions. Let's go here to 200. Now we can hide the wire display or the input for most of this stuff. Now check this out. Here's an interesting aspect to the units, right? So the units are inches, and it's giving us 240, which means it's 20 feet. So how do we make sure that when we bring in the units, it's going to be the right units? I want these to be in feet. So if this segment will go to length, and the length is going to then be divided by 12. So here we have 20. And now we can use that as a text input. And same thing here. We'll get the length divided by 12 and override the text input, which means that it will use that text So we have these dimensions and these dimensions, and we can change the size. Oh, maybe we should do that at the same time. So changing the size at the same time. Now we're not done yet because there's still some details that I want to add here, but for the most part, this is going to show you the overall steps that I take for creating a design like this. Obviously, there are unlimited ways of designing a building in a script, so this is just going to be a set of explanations and instructions to show you how I created this. Now, if you want to download this, you can find it on my website, and I also have collections and other things that are very similar to this that it could be useful for you as well. So with that being said, let's get into the next part. And if you have any questions or anything, make sure to let me know in the comments below. All right, so for this next part, right in here in between where we have the beams, we're going to be creating a set of inserted, like a pattern that's going to be inserted in here. So what we'll do is take some of the geometry that we already have. So I'll go back to this polyline. And using this polyline, what I'll do is I'll subdivide it. Now there's different ways we could do this. We could use Lunchbox, we could use Isotrim. In this particular one, I will be using Lunchbox, which is a plugin. So I'll go here to Triangle Panels B, and I will be using this polyline to create a surface. So boundary surface, and use that as the input for the surface. Now we'll keep the pattern fairly large for now. So let's go here to 10 subdivisions in the U and B. Now we'll take these panels and offset them to the inside. So we'll go here to offset, curve. And if we plug those panels into the curve input, we can offset it. And typically it offsets to the outside. So we'll bring in a negative component. And now we can offset it, let's say by 6.5. Now I also want to bring in a fillet radius and use slider here. So we can control the fillet here. So we'll go here to 2, hide this one, and then we'll create a surface without the outside pattern. We'll use this inside triangles and this outside surface or curve to create a surface. So we'll go to boundary surfaces between this outside polyline and this inside offset. Now notice that this is dashed and this is a solid line, which means this is grafted. And so it won't look at this as a whole list and it won't create the surface unless you flatten the input. Now, what we need to do is bring this pattern up to the top here. The first thing we need to do is move this surface up to where the columns are located. So we'll go here to column height and use the Z vector to move this up. And then we can actually add, so bring in an addition. We'll use this as A. We'll also need to add the beam depth. So that's going to be here 24. So Z vector this way. And I will make sure to keep this clean and plug this in. Now notice that what we did was bring it all the way up to where the floor slab is. And now what I'll do is extrude this down. So I'll bring in an extrude component in the negative direction using a Z vector. And I will use a slider here to lower 16.00. And so I'll go back and clean this up a little bit. Notice that we can change the subdivisions here. Lower this to 12. Maybe 16 or so. And then using this, we can array it vertically again. So I'll copy this component, slide it down, tap Alt, and I will array this one as well. And then hide the input for this one. And if we want to, we can give it a bit of a different color here. We can see how that design interlocks and intersects with the structure. So this gives it a very nice look, but it also helps structurally, where we'll make it lighter so you can have additional support for this part of the structure. Now, here's one thing I want to do actually. Make this dark like this, and let's include the light. So what I'll do here is take the pattern. So notice back here, we can go back to any part of the script. I'll go back to this portion, and I will turn those, or these, into a surface. So I'll go to boundary surfaces. And what I'll do is I'll move this up again to the top. So using this component, I'll just copy it and use that to bring up those segments. Then I will extrude it down again, but using a different slider. I'll organize it like this. And I'll use this one. So we have this one, and then I'll go up like this. Actually, we need to do its own. And if you want to, we could do 16 minus. And this will create an offset, so -6. So rather than using a different slider for the extrusion, we could just create an offset. So this is going to be the same, and we can say offsetted by 3 inches. Then we'll decrease this to, let's say, 24. And now I will take this and array it up. So I'll take these components, copy them down, and then use this input to array it vertically. But I'll make sure to change the color here. And so now we have lights within the structure that are integrated within the whole script as well. And we can change the number of floors. And all of those details are going to be included. And notice that when we do more subdivisions, it does tend to lag a little bit more, especially if we have a large array. So let's just do 2. And if we want to array it with a larger number, we could do that. Just notice how much longer it takes. And the offset we can change as well. So let's go here to 3. So with this video, I just wanted to share with you the process that it takes for creating some of these designs. The cool thing about this is we can change the inputs, create a completely different set of outputs, and let's array this a little bit more, like 5. And if you want to learn how this was done, you can download this script from my website, competidavid.com, and I also have other tutorials where I share with you free tips and tricks so you can learn how to program your own designs. I know there are some other details that I could add to this that will make it more structurally sound, like lateral supports, some rooms inside. For the most part, this is going to help with parametric design in general. So thank you for being here, and I hope to see you on the next one.